So yesterday we looked into orbital notation, and we also looked into shortcuts, right? But we looked into shortcuts, and then at the very end, so our ones that might have been missing at the very last few minutes, we went into orbital and electron configurations of ions. Okay? So an ion is something that has a different number of electrons than protons, right? And it changes their orbital notation or their electron configuration because you have a different amount of electrons in there. Okay? We looked at copper 2+, okay? And we did an example of copper 2+. I think we should do an example of like chlorine or something like that. The ion of chlorine. Okay? So let's just take another look and try and do the ion of chlorine just so that we have one more kind of under our belt. So does anyone know what the ion of chlorine actually is? Chlorine with a -1 charge. Why is it -1? Because it's in column 17 and it wants to gain 1 electron to become a full valence shell, or like the noble gas. Transition metals, remember, are kind of weird because of the fact that they're stuck in the D sublevels, and so they're down a main principal energy level. They're like, if you're in sublevel 4 or in principal energy level 4, the D's are in principal energy level 3. Okay, so the transition metals look a little differently, but the ones that are in columns 1 and 2 and 13 to 17 or 18 look different. So how many electrons are in a chlorine ion with a -1 charge? Well, we need to know what's the number of protons in chlorine. Protons are 17, and if we're gaining 1 more negative charge, that means our electrons are 18. So we need to draw, now it depends on what they say, either an orbital notation or electron configuration of chlorine. Which one do you guys want to do? So let's do the electron configuration. So if we do that, we can start without any shortcuts. We'd go 1s2, 2s2. Where do we have to go? Where's chlorine? Chlorine is in 3p's. So we have to go 3p and 1 more than what it is, 3p5, so 3p6 is where we need to go. So if we're going to write it, we'd write 1s2, 2s2, 2p. What goes up there? 2p. How many electrons it can hold 6. If you forgot how many electrons they can hold, how can you figure it out? Count the columns that are in the P area of our periodic table. Okay? Are we done? 2p6? That brings us to neon, right? So then we have sodium, magnesium, that's 3s2, 3p. Now chlorine is normally 5, but we added 1 more electron, so we should have 6. Okay? Now how do we know we have the correct number of electrons? You can add 6 plus 2 is 8, plus 6 is 14, plus 2 is 16, plus 2 is 18. So it gives you a total of 18 electrons, and that's what we had to display. Now, if we use the shortcut method, what's the rule about the shortcut method? You're supposed to take the noble gas that is just prior to it. Okay? So what's the noble gas just prior to chlorine? Neon. So we can also write it like square brackets neon What does it go to? Neon takes up 1s, 2s, 2p, so then I'm at 3s. So I'd write 3s squared, 3p6. Because neon takes 10 electrons, plus 2 is 12, plus 6 is 18 electrons. Okay? But what else has 18 electrons? Argon. Okay? Now, these are all ways of representing the the electron configuration of this. This one is a little bit of a real cheater method because of the fact that we're supposed to take the noble gas that's prior to the element, right? So if I'm talking about the best answers for orbital notation or electron configuration, sorry, this is electron configuration, you should follow that rule of the noble gas should be prior to the element you're dealing with, okay? Is this okay? Perfect. Are you guys okay with the difference between orbital notation and electron configuration? Is everyone okay with shortcut methods? Okay? As well as representing ions versus representing atoms. Okay, so the last thing that we need to talk about in notations is Lewis dot diagrams. So,
is there one over there for me?
You were here, Matt.
I wasn't. I missed that shit.
We had this for like 3 days.
So when we look at the last notation, some of you have seen these before. These are Lewis dot diagrams, electron dot notation. It's basically, the important part about this is that you're representing the valence electrons. So a lot of times we only see Lewis diagrams, if we're doing valence electrons, are ones that are in the S's and the P's of the periodic tables. So the ones that are from column 1, 2, or column 13, 14, 15, 16, 17, or 18, right? That's where we're going to see them. Some people or some places call them column 1 to 8 in Roman numerals, just because those are the main 8. Those are your valence 8. In order to write valence electrons in a Lewis structure or a Lewis dot diagram or an electron dot diagram, do you notice it has like many different names, but usually it has the word dot in it. Now, Lewis is the last name of the guy that invented this notation. So, the big thing, there's 2 steps. You write the symbol in the middle, then you draw the number of electrons around the outside, and you want to balance electrons. Electrons are all negatively charged. So, if you put an electron on one side, you want to put an electron on the exact opposite side. And then you put another electron on, and that would be the third side, and then to balance it out, the fourth side, the other electron. So it's like you're making a plus sign in some way. Okay? And then you add another electron to each one. Okay? So, if we look here, I've got the first 2 rows of the periodic table. Not the first 2, sorry. The second row and the third row, right? Is what I have on the periodic table here. The second row and the third row. And I have the symbol written already. So I've done the first step. We have the symbol. And the first column, how many valence electrons do we have? 1, because there's only 1 electron in that s outer orbital. Okay? So basically, the Lewis dot diagrams of anything in the first column is their symbol with one dot. Just so you know, it doesn't necessarily have to be on the top. It could be on the bottom or on either side, okay? It really depends on when we go into bonding and making covalent molecules, where do we want it situated around a central atom? So this second one, I want to see you draw it like this, top and bottom, because there's 2 valence electrons in column 2, or side and side. The big thing is electrons want to try and be farthest away from each other as they can. So some people, now I'm going to write this third one a couple different ways. Some people do 3 like this, up, down, and then to the side. Some people will do it side, side, up, down. Okay, so you end up with 3 electrons. Some people will even try and put them at the 3 corners so that they're completely equally spaced out. But the Lewis dot diagram a lot of times just plays with the 4 spots, one on top, one on the bottom, one on the side, one on the other side. So a lot of times I like to see this for a Lewis dot diagram, but we'll move into ones that are more visual or more like the aluminum one. Don't care specifically, as long as you have the symbol drawn right. And the big thing, don't draw your symbol with both capital letters. Bromine is capital B, little r. It's not capital B, capital R. If you write capital B, capital R, you're writing completely different things. Okay, you're writing boron and radon. Okay, you're not writing bromine. So anyone guess for 4? What does it look like? One on the top, one on the bottom, one on both sides. What about 5? Same thing. Top, bottom, side, side, and then you could go back to top, or you could go side, side, top, bottom, and go one on the side. As long as you have 5 dots, okay? And why would we pair them up? Because electrons fit into orbitals in pairs of 2, okay? So one of those orbitals is the s, one is px, one is py, and one is pz, right? So what does 6 one look like? Top, bottom, side, side, top, bottom. So you have 2 on the top, 2 on the bottom, 2 on the sides. Or you can go side, side, top, bottom, side, side again. As long as you have 6 dots, and basically, can I tell you something? They're probably sticking the electrons that are single on the opposite side because you're trying to level things out. Okay, for now, anyways. You can guess for 7s and you can guess for 8s. Yes, Cheyenne?
Is there a reason it's 7-7, like your group number?
Oh.
Subtractor or bigger?
This is group number 1 has 1 valence electron. Group number 2. Now, this group number, Roman numeral 3 and 4 and 5, some people in some periodic tables are called 13, 14, 15, 16, 17, and 18. But a lot of times they call them group 1A, 2A, 3A, 4A, and then your transition metals are called different things. So they really call them 1A, 2A, or 1, 2, 3, because it matches up with your valence electrons. That's a good question. Yeah?
Like the Roman numerals go 1, 2, 3, 4, 5, 6. You have 2 sevens.
Oh, that's what she's getting at. They should say 8 right here. Sorry. Good catch. Thanks for helping me read my questions. Okay, so 7, 1, 2, 3, 4, 5, 6, 7. Or 1, 2, 3, 4, 5, 6, 7. It really doesn't matter as long as you have 7 dots around and you've paired 3 of them and left 1 single. Okay? And then with your 8, 1, 2, I should go around like like normal, do 1, 2, 3, 4, 1, 2, 3, 4 to give me a total of 8. If you have neon, not neon, sorry, helium only has 2 valence electrons. You could put one on either side. You could pair them together because they're really in one orbital together. That's probably the only time you can draw 2 electrons and put them together because they're paired together in that 1s orbital. Okay? So, none of this. I want to exit. So, before I let you guys go, at the very bottom of this page, there's questions, right? Those are questions that we need to complete and hand in. I'm okay, but can you listen? There's probably not a lot of room. Does it ask for electron configurations or orbital notations? Okay? You're going to have to know both, okay? I'm okay if you do all electron configurations or if you do electron configurations and orbital notations, but you can only do 2 shortcuts. A max of 2 shortcuts, the rest have to be done long ways, okay? You can show work on a different page or you can do it on that page if there's room. A maximum of 2 shortcuts. I would like you to practice because I want you to be able to read both ways. Okay?